In this problem, we have student A applying a force of 50 newtons in the positive x direction to a box of mass 20 kilograms on a horizontal surface. Student B is pulling a rope attached to the box with a force of 25 newtons at an angle of 55 degrees above the positive x-axis. The coefficient of kinetic friction between the box and the surface is 0.2. What is the acceleration of the box in the x direction? Alright, since we want to know what the acceleration of the box is, for step 1, we're going to say box. So we're going to sum the forces on the box. For step 2, let's go through a problem. So the first thing it says is that student A is applying a force in the positive x direction on the box. So we're going to say force applied is in the positive x direction. Then it says that the box has a mass of 20 kilograms, so that tells us the box has a weight of 20 kilograms times 9.8 that acts in the negative y direction. Let's see, student B is pulling on a rope attached to the box. So that means we have a force of tension, let's see, 55 degrees above the positive x-axis. So that's going to be positive x, positive y. And we're going to follow that at force due to tension. And let's go back, because I skipped the fact that it was on a surface. So a surface means that we have a force normal. Since this is a horizontal surface, the force normal is going to be in the vertical. So we're going to have force normal in the positive y direction. Let's see, what else is there? So there's a coefficient of friction. This tells us that there's a force of friction. And since the box is accelerating, that tells us that we're dealing with a force due to kinetic friction. And since the object is going to move in the positive x, because the surface is horizontal, so we're only worried about the x for this question, we're going to say the force due to friction is in the negative x. Alright, so let's move on to step 3. So let's see, in the positive y, we have the force normal. In our first quadrant, we have a force due to tension. In the positive x, we have a force applied. In the negative y, we have a force due to gravity. And in the negative x, we have a force due to friction. Specifically kinetic. And we have to remember that force due to tension has an x component and a y component to it. Alright, so let's move on to let's see, this was step 3, so we need to do step 4. Alright, so in the x direction, we have the force applied. We have the x component of the force due to tension. And then we have the force due to friction kinetic. That's going to sum the mass times acceleration, the x. And since the x component of the force due to tension is adjacent, we can sub in cosine. And we're asked for the acceleration, the x, so it can't be 0. So therefore, we need to leave it there. Alright, so let's move on to the y equation. See, in the y direction, we have a positive force normal, we have a negative force due to gravity, and then we have a positive force due to tension in the y. That's going to equal mass times acceleration in the y. And since the y component is opposite, we can sub in sine. Alright, so we're trying to find the acceleration in the x. So let's start with our x direction equation. Okay, so we have force applied, that's given in the problem, so we're going to say 50 newtons. Force due to tension is 25 newtons, also given in the problem, and we know the angle, so we can sub that in as well. We don't know what the force due to friction is. Alright, so we're going to have to try to do something else to find the force due to friction. So we know that the force due to friction, kinetic, is equal to the coefficient of kinetic friction times the force normal. We're given the coefficient in the problem, so if we find the force normal, we can use this equation to find the force due to friction. So let's try our y direction equation, because that's where the force normal is. So force normal minus m times g, because that's what the force due to gravity equals, because we're given mass in the problem, not weight. That's force due to tension, sine of theta. And we can say the acceleration of y is 0, because we're not bouncing the object up and down. Alright, so force normal minus 20 kilograms times 9.8 meters per second squared. Remember, we're plugging in positive because we already took care of the minus sign. plus the tension given, so 25 newtons times the sine of 55 degrees is going to sum to 0. So that's going to give us a force normal that equals 176 newtons. So I can then sub it in back over here. Our coefficient given in the problem is 0.2 times 176 newtons. So that is going to equal 35.2 newtons. So we can plug that 35.2 newtons in up here. 20 kilograms for the mass times acceleration in the x. So acceleration in the x is going to equal 1.46 meters per second squared.